is going on, YouTube? Welcome back to the channel. I got another project for you guys. We are going to be joining the Honda world today. So shout out to my boy Nico for trusting me on a repair job for this. So the issue with this is for a B18, I believe it is, B18 B1 or C1, something like that. I'm not sure if it's a GSR, but anyways, this is a forward-facing turbo manifold. I love these setups because it allows the turbo to, you can cut a little hole in the front bumper so you have that ultimate airflow. The issue with this is I don't know who made it. I'm not sure the brand of this turbo manifold or whatever it is. Unfortunately, to me it seems like it's cheaply made, or just the fit up and everything on it is kind of lazy. I want to say I don't like to bash anybody or anything, but the pipes, like they don't butt up together perfectly, like they're a little offset, so that's going to interfere flow. It does feel like it's about schedule 10 piping, so let me do something for you guys. I have a little. Alright guys, so now this is with my iPhone. The quality camera is just so much better on the iPhone, but the GoPro is a lot easier to use. But the crack that we're looking for is that one. Now I just tried to brush it off with a stainless brush, and it kind of made all the soot and everything go away, so now it's a little harder to see the crack. But I hope you guys can see it. Like, there's one right there, and it goes all the way across. Not sure if you guys can see it there neither. I hope you guys can really see the crack. Anyways, I hope you guys can really see the crack on there. But he had exhaust leaks and everything on there, and also you do have like a 20-30 pound turbo that's hanging off of the turbo manifold. When it's bolted up to the head like this, all the weight is right here, so it is a lot of stress on that weld. So it is very important that you have a nice deep penetration, you have back purge, you have no sugaring on the pipe. And basically the reason I believe this manifold caused a crack on there is because from all the welds that I'm looking at this, it does look like it has a lack of penetration and a lack of filler. So back to the iPhone camera, I'm going to show you guys why I say it has a lack of filler. Alright guys, we're back on the iPhone camera. So the reason I say lack of filler is because for this 1.5 inch schedule 10 pipe, these welds do look a little way too small. And if you just keep on going, you can see that there's still a little alley inside where the joints go. So whoever made this manifold could have filled that up with more material, more filler wire. That way you have a bigger, basically you want a lump of weld here, or flush. But since you still have a little alley inside there, that's showing me that's a lack of filler. That looks like maybe it was just like, maybe a root pass or something, but you should have topped that off. So I do believe that this manifold is going to come up with more cracks in the future. We can just see everything else on here. There's alleys there. There's just alleys all over the place. So So I did warn Nico about it. I did tell him that this might, get more cracks in the future. If you want, I can fully re-weld this manifold and everything. I can just repair the crack, or maybe we can work together in the future and I'll just make you a completely brand new turbo manifold. But like I said, I think his goal is just to get the car running and everything. So today we're just gonna fix the crack. I'm gonna show you guys how I do that. And I'm gonna see if I can work a little bit of magic on the manifold, at least, polish it up, because it is all, used and corroded and everything. So I wanna make it at least look nice. So let's go ahead and do that. In order to do that, the goal is usually when you go to repair a crack, what you want to do is you wanna drill a hole at the beginning of the crack and at the end of the crack. So the reason you want to do that is because you're relieving all the stress marks all the stress that's inside that steel or the material. If you just do if you just go to do a pass weld over it, you still have that chance of the crack still being at the bottom of your weld, and that crack is just going to keep on going. So the goal is you always want to drill a hole at the beginning of the crack and at the end of the crack. Unfortunately, we cannot do that on this manifold at the crack that it's at, because I cannot put a drill inside the location that it's in because it's between one of the runners. So what we're gonna do is, I got a new tool for Christmas. Shout out to my girlfriend. She got me a bunch of new tools. Also shout out to my boy Hector for getting me a whole brand new Snap-on toolbox that has fucking everything loaded in there. You guys just made my job so much easier. She got me a nice little Milwaukee die grinder. Shout out to Milwaukee. I fucking love all your tools. So what we're gonna do is we're gonna put a carbide bit on here. Also shout out to Wilson Products, who supplies all of my welding supplies, all my filler rods, all of my gas for my argon, all of my tungstens, all of my carbide bits, everything I buy from Wilson Products. Even my new Miller gloves, man, love these things. Anyways, getting off track there. So what we're gonna do is we're gonna switch out to a carbide bit. We're gonna go with a I like to call it the Christmas tree bit. It's like a nice little pointed end, and then from there we're just gonna go over the weld and everything. We're gonna clean it all out, make sure it's fresh and it's gouged. It's gonna create a little bevel on there, and then from there we're gonna be able to put some fresh filler in there. Before we do that, obviously clean it with acetone. It does have soot inside the manifold since it is used, so we got to keep all of that in mind. I do have to seal it up and everything. We got to be able to back purge it as well, so we're gonna do some aluminum foil. We're gonna stick my hose inside here on the runner. We're going to close off the head runners. We're going to close off the wastegates, and that should allow me to back purge perfect. So other than that, let me get this bad boy swept out, the battery plugged in, and let's start cleaning up. Alright guys, so we have a Milwaukee setup. The only thing about fucking Milwaukee die grinders is it's a fucking bitch to get off the bits, bro. I was just fighting this shit for like 20 minutes trying to get that bit out. Because the way that the Milwaukees are set up, you're supposed to put your bit all the way back, and when you loosen up this collar nut, it's supposed to be able to push it out. But since I'm using like shank style bits on here, it has nowhere to actually grab, so it's a fucking bitch to get it out. It's the only downside about these. But anyways, let me get my battery. Let's keep on going. Alright guys, battery's in, shank's in, powered on. Safety glasses, don't forget safety glasses, especially when you're grinding. These little metal shavings are no joke. Get them shits in your eye, it's a wrap. So now what we're gonna do is we're gonna go on the crack, which is here, and we're gonna do some grinding. We're gonna polish it up. I'm gonna be able to show you guys a little bit of clips on here, but once I start getting into tighter spaces and everything, it's kind of hard to show you guys, but I will show you guys the end product. So let me just do a little bit here with you guys. Most of the manifold grounded out, so you put a nice little groove inside there. I'm not sure if you guys can see how deep that really is, but that's going to expose most of the crack as much as possible. Now I can't really get all the way around it, so like on this side of the manifold, do now is I'm going to grab my grinder with my new flap wheels. I ordered a set off of these off of Amazon. These are basically Scotch-Brite pads, but these are for like your grinders, so that way you can polish up the stainless and everything. So now I'm gonna share with you guys a secret that apparently everybody likes to keep to themselves, but I don't care. I'm gonna share with you guys. So for the longest, when you join to fabrication and everything, the ultimate goal is to have the nicest appearing material, correct? You want a nice shiny manifold with nice rainbows and everything. Now sometimes when you order material, it comes with mill scale on it. So now in order to get rid of that mill scale, you need to basically prep your material. You gotta, you know, make sure everything's good to go. Now for the longest, I could never figure out, or nobody would like to share with me, how do they polish their stainless, or how do they There's Muller polish. I have also a polishing wheel on my bench grinder, and there I'm able to get my materials all nice and shiny. So Scotch-Brite wheels are your friends. These are what makes your materials and everything so much nicer. So other than that, let's get this manifold cleaned up with these bad boys, and let's lay down some welds, baby. Gotta eat lunch. But we did the major polishing with the flap discs, or the, I don't even know what to really call them. The Scotch-Brite flap discs is what I'm gonna call them. Anyways, we finished the major polishing with that. We still gotta get inside some runners. You know, we'll do that by hand with some regular Scotch-Brite. But I hope you guys can see the difference on what it used to look like compared to how it is now. We'll just do some finished polishing, and then we'll clean it with acetone, and we'll do our weld. And this manifold should be good to go for our customer Nico. So let me finish my lunch. Alright guys, so we have the manifold all polished up as best as we could. You know, it's kind of hard with the runners and everything in between, but it's a huge difference from what it looked like when it came in. I do not offer the polishing with every job that I do. You know, you got to pay for it, but when I do offer it, I do it as best as I can. So like I said, these are the magic. So now what we're gonna do is we're gonna tape off the runners and everything. I'm gonna put you guys back on my stand. We're gonna tape off my runners. I usually use duct tape, but I can't find my duct tape, so we're just gonna use some painter's tape. There's nothing important. This tape is not really gonna see any heat. I just needed to block off all the ports so my argon cannot escape, and I can keep all of my argon inside of the runners so I don't create any sugaring with the new wells that we're gonna put in. So I'll have you guys here in the process with that with me. I'm just gonna cut off any of the excess tape. Put that to the side. Now for the future, I do wanna learn. I do want to build my own, I guess you can call it like a tumbler polish. Basically like a big tub that you put like ceramic beads and everything inside with a soapy additive or whatever the fuck they put inside there. And basically you just put your part inside of that tub, and it has like ultrasonic vibration inside, and it automatically polishes it for you. It does take a while, but that's the ultimate way to get anything polished or cleaned up at that. So I do want to build one of those for the future. If you guys have seen my other videos, which I hope you have, if you have not, please go check those out. I do a lot of fabrication, and I build single turbo kits for the BMW M54s. I built hood dumps for the BMW 550s and the BMW X5M as well. I'm telling you, 2023, I want to expand. I want to find new things to work on. But basically, I work out of a one-car garage, so I need to build a pole barn. So I want to build a at least 2-car garage, so I have some more work to room in, some more room to work in, I should say. Sorry. But yeah, that's, you know, future goals. It's kind of hard working out of a one-car garage, you know, trying to do fabrication, cars coming in and out all the time. It just sucks. So future investment, I will be getting a pole barn garage. And when I do that, I want to film, you know, them coming in, laying the concrete and all that stuff. So it'll be pretty cool for you guys. Nice little time-lapse video. Let me get my back purge hose going. So I use a 3mm hose connected to my argon bottle, which you can see here, I hope. So it's a dual ball regulator. One feeds the argon to my welder, and then the other one feeds argon to my hose. So the hose I just stuff inside the manifold, and what it's going to do is going to get rid of any oxygen that's inside of the manifold, because when you weld stainless, basically it interacts with the atmosphere that we have in the oxygen, so it creates sugaring. You do not want sugaring inside of a turbo manifold. Like I said earlier in the video, you want your exhaust flow to flow as smooth as possible. So in order to do that, one is, you know, material fitting up to each other, make sure everything lines up great. And then two is to have a nice clean weld. So in order to have a nice clean weld on the inside of the manifold while you're welding the outside, you change out the oxygen atmosphere that's inside the manifold with argon. So that is what back purging means. Poke a hole. I'm gonna shove my line in there, and we're gonna go on this runner. So I want my argon hose to go inside there, which is right here. So I'm gonna face it towards there, and I'm gonna cover it back up with more tape. You want to seal it all off really nicely. Put a little bit more. I don't want to risk that line coming out, God forbid. You know, it's just painter's tape, a couple bucks. Don't be greedy. You want your job to be the best. Now, I have my argon hose in there. Everything is taped off. It is good and it's very bad at the same time. You got to remember, we're pumping argon inside here. So technically we're adding pressure, correct? So now, since everything is topped off, there's nowhere for that argon to go or anywhere for that oxygen to be displaced at neither. So what you need to do is you need to poke vent holes. So since I'm welding this runner, I'm going to poke just a tiny little vent hole here. What that's going to do is going to allow the argon to take all that oxygen out of there, and it's going to displace oxygen out while it's pumping fresh argon. Also, since it's pressurized, you need a vent, because if I go to finish that last weld and I seal it up, as soon as I go to seal it up, remember it's pressurized, so since that's molten metal, it's technically like a liquid, it's going to blow out on me. So you need a vent so you don't have what's called blowout. So we're going to put a little vent hole right here, as small as possible. I'm just going to use my tungsten, since my tungsten is very sharp. I like to TIG weld with a sharp tungsten. So I'm just going to go in there and I'll poke maybe 3 holes, you know, nothing big. So now I am 100% sealed off. I'm going to turn on my argon bottle. And then, actually, let me take you guys with me. This is my setup, dual regulator. So this one feeds argon to my welder. I use the Vulcan Pro TIG 205. In case you guys haven't seen any of my other videos, I absolutely love this welder. You know, for a beginner on a budget, this welder costed me, I think, like $1,200 with 3-year warranty. You can weld AC, DC, stick, everything with it. So this is gonna feed argon to my welder. I'm using a ferric BBW cup, so I pump around 30 CFH of argon. Now this is going to be my back purge. So what we're going to do is we're going to turn the back purge up to around 15, and we're just going to leave it back purging the manifold for about 30 seconds to a minute. you know, just make sure all the oxygen is out. And then when I am comfortable with it, I can start welding. But before we do that, I'm gonna start prepping the material while it's getting pumped with argon. I have a clean microfiber towel here, and then I have my water bottle full of acetone. Go to your local parts store or whatever, buy yourself a big jug. I don't like to pour this thing into a rag because you make a mess. I just pour it into a little water bottle, and then I just pour a little bit at a time. So I'll grab my microfiber, I'll double fold it, tap it in a little bit, and then I'll go clean the area that I'm going to be welding. Make sure there's no oils, any soot, any fingerprints, nothing's on there, and I'll have a nice clean strong weld. So we're going to make sure we get all the way around there, go between the runners, in and out, make sure it's all nice and clean. Now I'm not going to be worrying about wire brushing it because I just cleaned the whole material with Scotch-Brite, and now I'm covering it up with some acetone, so it's 100% clean. We are ready to lay down a nice weld. So a couple seconds in, and I'll let it back purge, and then I'm gonna start getting ready. I'm gonna take off my safety glasses. Sorry about that, guys. I had the customer for the single turbo kit that I just built in my last video. He was here, he was chilling, he just came to pick it up. He loved it. He also bought some merchandise. If you guys haven't seen my last video, I do finally have Frenchy Fab merchandise. I have sweaters, t-shirts, I even have sweatpants as well. The Frenchy Fab logo is here at the bottom. I do not have a pair on at the moment, but if you guys would like to support, please like, subscribe, comment, share my videos. And you guys can even buy merchandise. You guys can either follow me and send me a DM on Instagram at Frenchy Fab. I finally do now have a official Frenchy Fab Facebook page as well. You guys can also follow me on TikTok, Frenchy Fab _ Frenchy _ Fab, and also my YouTube channel. So I love this stuff. If you guys want to see any certain kind of things, if you guys want me to fabricate certain kind of things, comment that stuff, man. I like challenges. But other than that, it's all clean. It's back purged. It's been back purging for a couple of it's about a minute now. We're all ready to go. So now the filler wire that I'm gonna be using is 1/16 304L. So this is to weld 100% stainless. If this was stainless to steel, then I'll be using a 309 filler wire. But material's all cleaned. My filler is all already prepped. It's all clean. I have everything ready to go. I just have my tungsten, and I'm just gonna clean off the tungsten a little bit because I was with Scotch-Brite, so I'm not sure if there's any dirt or anything on there. So we are gonna be turning up my welder to 85 amps. Not sure if you guys heard me, but I said I'm gonna be turning up the welder to 85 amps. I might not be using all the 85 amps, but if I need it, it's gonna be there. All of my amperage is controlled on my foot pedal. But other than that, let's get to repairing, baby. hear me, let me shut that shit off. Alright, welder's shut off. Job is done. So we completed the weld. It is a little hard getting around this runner, you know what I mean? So everyone thinks that a weld should always look perfect. Unfortunately, sometimes it's just in the nature when you go to do a repair like this, or even out in the field. I'm a welder out in the field. This is just what I do as a hobby. Sometimes you run into obstacles. There's shit in the way. You can't always get the torch in there perfectly. So this runner gave me a little bit of an issue, but we overcame it. The trick that I like to do is I'll extend my tungsten out more than usual. So right now it's about 1.5 inches extended out, or 1.25 inches I should say. My tungsten's sticking out. Now a lot of people get scared and they're always asking, why is your tungsten sticking out so big, so long? It's because I use a BB cup. So the wider the cup, the longer you are able to extend the tungsten in. Now I'm overextending it what it's rated for, but what I do is I turn up the argon a little bit more. I turn it up to 40 instead of 30 CFH. That way I still have more gas coverage even though my tungsten is a little bit further out. It works for me. I never have an issue, especially if you're inside an area where you don't really have a breeze or anything going on. You're good to go. So let me show you guys what the weld looks like. So this is what the welds came on the manifold. You know, they had the little galleys and all that stuff. Lack of penetration somewhere, so I'm not sure if you can really see it too well. Over here you'll be able to see it. So there we have a nice fat bead profile on there. What should have been on there for a Schedule 10 pipe. So it's on there real nicely. So now I decided to hit up the customer, hit up my boy Nico, and tell him that his manifold is done. But that's today's job. I figured I'd show you guys, you know, a little bit of repairs, not just fabricating all the time. Sometimes we just have to do repairs. This was today's job. So if you guys remember what it looked like when it first came in compared to what it looks like now, the crack is fixed. It was back purged and everything, so there's no shit going on. And hopefully we can get this car back up on the road. But I appreciate you guys sticking out with me today. Please like, subscribe, follow, go check out my Instagram, my TikToks and all that. And if you guys would like some merchandise, please just send me a DM and then we'll get you guys set up. But thank you guys, and we'll see you guys on the next one.